Hello friends, this is lecture number 18 of EMT. This is my Insta ID Lakhyajit 123. If you want to follow me on Insta, you can follow me. And today we're going to discuss about electromagnetic wave in dielectric medium. Right. So before we start, please subscribe the channel, hit the thumbs up button, and also hit the bell icon so that you get notified when new video will be uploaded. Right. So now let's start. So electromagnetic waves in dielectric medium. Electromagnetic waves in dielectric medium. Now you see, first we must know the Maxwell equations, right? So what are the Maxwell equations? Maxwell's equations. Del dot E, which represents electric field, is rho by epsilon naught. But for dielectric medium, the free charge is 0. So in dielectric, just let me write it here. Maxwell equations for dielectric medium. So we can write here 0 directly, right? And del dot B represents magnetic field, which is also equal to 0, and del cross E, that means curl of E, is given by minus del B by del T, and here you see we can write that B is equal to mu H, right, where mu represents permeability. Right. So that's why we can write this one in this way: mu del T of H. We can write that way. Then the next equation, curl H, that's given by Z vector plus, that's B divided by del T, right? So these are the equations. So you're gonna have, so this is equation number 1, 2, 3, 4. These are the Maxwell equations. Now taking curl of equation number 3, so if we take curl of equation number 3, then what we're gonna have, curl, so let me write the left hand side of the equation number 3. We are going to take curl of this, then again take the right hand side. So here is the right hand side, and as we are taking curl, we can write this one like this way. This can be written this way, curl of H. That's how we can write. So that's how we can take curl. Okay, so now let me copy this equation and let me go to the next slide. Okay, let me copy this whole part. Okay, let me go to the next slide. So here you see, now you see, if we use a vector identity, so hope you know that identity, curl of a vector is given by del dot of that vector minus del square that vector, whatever be the vector is. So here in this case we are taking E, right, then minus mu, and we can replace this by this result, right? So what we're gonna have, del t of this. Just let me copy this. Just wait. So you have got this, and this is obtained from I have used this result from equation number 4, right? Using equation number 4, right? And this implies, here you see, as we have got del dot E in dielectric medium is 0, so we can put here 0, so this whole term becomes 0. So that's why we're gonna get minus del square E vector is equal to, then we can write minus mu z del z by del t, then minus mu del second order derivative, partial derivative of this displacement d by with respect to t, right? And that's what we're gonna have. And we know that d is nothing but epsilon into E, where epsilon is the permittivity, right, of the dielectric medium, of the medium. So that's why this let me just scroll down the page, let me copy these things. Okay, so hope you have noted these things. Pause the video and note it down. So now you see minus del square E, and let me mention one more thing. I have used equation number 1 here, just wait. So I got this one is equal to 0 from equation number 1, or using 1, you can write using 1, where we had got in equation number 1 we had got del dot E is equal to 0. This was the equation number 1, we have used that value here, so that's why we have got 0 here, right? So now mu partial derivative of z with respect to t, then mu second order partial derivative of, instead of d we can write this one, so epsilon is coming out here, this is epsilon, right? Then second order derivative of E with respect to t, right? That's what we're gonna have. Okay, so this implies minus mu del z by del t minus mu epsilon second order partial derivative of E with respect to t, right, is equal to 0. So this is electromagnetic wave equation, right? So similarly we can obtain such electromagnetic wave equation, we can obtain such equation for magnetic field as well. So similarly, let me scroll down the page. Okay, similarly, taking curl of equation number 4. So what was the equation number 4? If you go to previous slide, here you see this is the equation number. Here is the equation number 4. If you take curl of this equation number 4, taking curl of equation number 4, what we're gonna get? We're gonna get this. Okay, so we have taken curl of equation number 4. So again, if we apply the vector identity here, then again we're gonna get del of del dot H minus del square H vector, then del cross Z plus we can write del T of del cross D, right? we can write this way. One more thing, let me write here. This j can be replaced by sigma e, right? And if we do so, then this term becomes sigma, sorry, let me write it properly, mu sigma del E by del D. That's what we're gonna get, right? So similarly here we can replace the J, okay, and here again you can see that H is nothing but B by mu, and if you take del dot H and del dot B, and in second equation we have got del dot B is equal to 0 in Maxwell's second equation. This is equation number 2, so that's why this part gonna be equal to 0, right? This part gonna be equal to 0 minus del square H vector here. Then so now let us replace this J by this value of J. In that case, what we're gonna have here, we're gonna have sigma del cross E, then plus, and we can replace D by epsilon X, and then we're gonna get here epsilon del T of del cross E. That's what we're gonna have, right? So what are the values we have used here? And we have used here, since del dot B is equal to 0, then we have used that we also have used B is equal to mu into H, and we also have used here D is equal to epsilon E, right? That's what we have. These are the results we have used in this equation. So now again we are to find the equation for H. That's why again we have to do some substitution. So let me copy this. And let me go to the new slide. So here is the last step we have got. Now in equation number 3 we have got this, right? This is equation number 3. Let me write here, just read. Let me cut this, we don't need this part. And this is the equation number 3, right? Just let me rearrange these things. Okay, so this equation we are going to use here. So we're going to replace this del cross E by this result. Okay, so then what we're going to get, del square H is equal to sigma. If we use this result, then what we're going to have, so we have to use this result, plus epsilon del T. Then again we're going to use here this result, right? So using equation number 3. So now it can be written, so I forgot the minus here, minus sign, vector H, that's going to be minus mu sigma del H by del T, right? Then mu minus mu epsilon second order derivative of H with respect to T. That's what we're gonna get, right? So this equation gonna be equal to this, sorry. Just wait. So this is what we have got. Now you see this equation, and let me go back to the previous slide, this one. So these two equations, this is suppose equation number 5, and let me copy this equation as well. This is suppose equation number 5. Here is the equation. Let me write here. Just wait. And this is equation number 4. Sorry, not 4. This is equation number 6. Right. This is equation number 6. Just wait. So this one is equation number 6, and so we have got this in previous slide, equation number 5. This one equation number 5. This is T. So this is equation number 5. Here you see, this is the equation number 5. This two, equation number 6 and 5. Equation number 6 and equation number 5 are EM wave equations in dielectric medium. Right. So thank you for watching, and